Hello, my friend, and welcome to the Sleepy Scholar. Tonight, we are not going to talk about a place. We are going to talk about a neighborhood, a small, quiet neighborhood of light and stone and gas, spinning slowly in an otherwise empty dark. Some people call it the solar system, but really, it is more like a single breath the sun took billions of years ago that never quite finished exhaling. And everything around it, every planet, every moon, every drifting fragment of ice, is still riding on that one long, unhurried breath. You don't have to hold onto any of that. You don't have to remember a single word of what I just said. If you're here tonight, maybe your day was long. Maybe your thoughts have been busy, circling the same worries over and over, refusing to settle. That's all right. You don't need cosmic mysteries or deep philosophy to fall asleep. You just need somewhere soft to rest your attention while your body does what it already knows how to do. That's all this is, a soft place to rest. So tonight, we'll wander gently through our own solar system, not to study it, not to memorize it, just to let it hold you for a little while. There is nowhere else you need to be tonight, nothing to prepare for, nothing to figure out, just this quiet drifting together. And if these gentle journeys ever help you rest, you're welcome to like or subscribe, not because you need to, but because it helps other sleepy souls find their way here too, to this same soft, unhurried place. Now, before we go anywhere at all, let's just arrive here in your body, in this moment. Let your body soften into whatever is holding you right now, the bed, the couch, the floor. You don't have to do anything with this softness. Just notice it happening. Let your breathing slow on its own without forcing it. Follow it if you like, or don't. Either way is fine. Let your shoulders loosen just slightly, like something you've been carrying is finally allowed to be set down. Let your jaw unclench. Let your forehead smooth. Let your hands go still and heavy. You don't need to remember anything I say tonight. You don't need to follow the thread of it. If your mind drifts away entirely and comes back 5 minutes later, that's not a failure. That's exactly how this is supposed to work. Nothing here is a test. There is no version of tonight where you do this wrong. Your mind, underneath all its noise, is really just a quiet machine trying to make sense of a busy day. It's been guessing and predicting and bracing itself since the moment you woke up. Tonight, it doesn't have to do that anymore. It can let this voice do the guessing for a while. It can rest. So let your mind drift as we begin. Our sun is older than almost anything you could picture, and yet somehow it is still young by the standards of the universe around it. Right now, deep in its core, hydrogen is being pressed together so fiercely that it becomes helium, releasing light in the process, light that has been traveling for a very long time before it ever reaches you. That light didn't leave the sun's surface just now. It's been trapped inside the sun for tens of thousands of years, bouncing from particle to particle, before finally escaping into space and taking a little over 8 minutes to reach your eyes. So the sunlight you saw today wasn't new. It was old light, finally arriving. A patient kind of light that waited its whole journey just to warm your skin for a moment. Somewhere inside you, right now, that same 8 minutes old light helped grow the food you ate today, warmed the air around you, and quietly kept the whole rhythm of your day turning. You've been living inside sunlight your entire life without ever needing to think about how old it really is. But that is only one small part of the story. The surface of the sun is not smooth or still, the way it looks from here. If you could shrink down and float just above it, you would see it boiling, vast cells of glowing gas rising and falling, each one roughly the size of a country, constantly bubbling like a slow, endless pot of light. These cells are called granules, and each one lasts only about 20 minutes before dissolving and reforming. The entire visible surface of the sun is made of millions of these shapes, rising and sinking in a rhythm too slow and too vast for a human eye to notice without watching very, very closely. It's strange to think that something so enormous could be, in its own way, breathing, swelling, and settling over and over, the way your own chest rises and falls right now. There is something else worth resting on for a moment. The sun doesn't just send us light. It sends us wind, an endless stream of tiny charged particles pouring off its surface and drifting outward through space, called the solar wind. Some of these particles eventually reach Earth, and when they do, our planet's magnetic field gently redirects them toward the poles. There, high above the frozen north and south, those particles collide with the air and glow soft ribbons of green and violet and pale rose, folding and unfolding across the night sky. This is the aurora. It is, in a very real sense, the sun's breath brushing against our planet's skin. You may never have stood beneath one, but somewhere tonight, someone is watching that quiet glow ripple overhead, made from a wind that began on the surface of a star. Let's drift a little closer to home now and rest for a while on Mercury, the smallest planet and the closest to that endless furnace. Mercury has almost no atmosphere at all, nothing thick enough to hold warmth or soften the extremes. Because of this, its days can grow hotter than an oven, while its nights can fall colder than anywhere on Earth ever gets. All on the very same small, rocky world. There is no wind there to blur the light, no clouds to soften the shadows, just bare, ancient stone, cratered by impacts that happened so long ago, there has been nothing since to smooth them over. Imagine a place with no weather at all, no breeze, no rain, no gentle in-between. Nothing to interrupt the silence. Just heat, then dark, then heat again, endlessly. It makes the mild, changing air around you tonight feel like a small and quiet gift. But that is only one small part of the story. Here is something gently strange about Mercury. A single day there, from one sunrise to the next, is actually longer than its entire year. Mercury spins very slowly, but it orbits the sun very quickly, completing a full loop in only about 88 Earth days. Because of the way its spin and orbit overlap, if you stood on its surface, you would have to wait almost 176 Earth days just to see the sun set and rise again. Time moves differently there, not faster, not slower exactly, just arranged in an order our minds don't expect. A whole year could pass, twice over, before a single sunset finally arrived. You never have to wait that long for anything tonight. Your own night is already so much gentler than that. Let's drift onward now to Venus, often called Earth's twin, though it hides a much fiercer secret beneath its soft, glowing clouds. Venus is the hottest planet in our solar system, even hotter than Mercury, despite being farther from the sun. This happens because its atmosphere is so thick, so dense with carbon dioxide, that heat becomes trapped there and never truly escapes. It's a little like a blanket pulled far too tight, never allowed to loosen. The clouds themselves are not soft and white the way ours can be. They are made of sulfuric acid, drifting high above a surface hot enough to melt certain metals. And strangely, Venus spins backward compared to almost every other planet, so slowly that a single day there lasts longer than its entire year, just like Mercury, but for very different reasons. It's a beautiful thing, in a way, to think of a planet wrapped so tightly in its own atmosphere that it can never release its heat, and to feel, by comparison, how gently your own breath moves in and out right now, warming and cooling, always finding its balance again. There is something else worth resting on for a moment. From here on Earth, Venus is often the brightest point of light in our evening or morning sky, sometimes mistaken for a star. Ancient people across many cultures noticed it long before they understood what it was, giving it names tied to gods of love, war, or the dawn. A bright wandering light that seemed to belong to no fixed place. It's strange to think that something so hostile up close could look, from such a distance, so calm and lovely. A single steady point of light, glowing gently above the horizon, while the rest of the sky settles into evening. Maybe that's true of a lot of things. Distance can turn even the fiercest places into something quiet and beautiful to look at. Let's rest for a while now on our own planet, the only place, as far as we know, where any of this wondering is even possible. Earth is wrapped in a thin, invisible shield called a magnetic field, generated deep within its molten iron core. This field quietly deflects most of the sun's harsher particles before they ever reach the surface, protecting the delicate balance of air and water that allows anything at all to live here. You have never had to think about this shield, not once in your whole life, and yet it has been working every single moment, silently standing between you and a much harsher universe. There is a kind of comfort in realizing how much has been quietly protecting you without your ever noticing, how much stillness and safety have simply been given to you freely your whole life long. But that is only one small part of the story. Long ago, in Earth's early history, something enormous struck our planet, an object roughly the size of Mars, colliding with the young Earth in a moment of unimaginable violence. Out of the debris thrown into orbit by that impact, our moon slowly gathered itself together. So the moon you might glimpse through your window tonight is not a separate, unrelated thing. It is, in a very real sense, a piece of Earth itself, flung into the sky so long ago that the violence of its beginning has long since settled into something calm and steady and familiar. It's a strange kind of comfort, knowing that even our gentlest nightly companion was born from something so chaotic, and that chaos, given enough time, can soften into quiet beauty. There is something else worth resting on for a moment. The moon is slowly drifting away from us, moving outward by about the width of a coin every year. It is so gradual that in your entire lifetime, the distance will barely change at all. And yet, over hundreds of millions of years, it adds up to something enormous. Because of this slow drift, the moon's gravity is also slowly changing the length of our days, stretching them by fractions of a second over vast stretches of time. Long ago, a single day on Earth was several hours shorter than it is now. You don't have to hold onto any of these numbers, just the feeling of it, that even something as steady and familiar as the length of a day has been quietly shifting, slowly, patiently, for longer than any living thing has been here to notice. Let's linger a little longer near the moon on something softer. Moonlight is not really the moon's own light at all. The moon has no glow of its own. It is simply reflecting sunlight, bouncing pale, and cool off its gray, dusty surface before drifting down to us. So even in the deepest part of the night, when the sun feels impossibly far away, its light is still somehow reaching you, borrowed and softened, carried the last part of its journey by the moon. In a quiet way, you are never really apart from sunlight, even here, even now, even in the dark. Let's drift onward now, toward Mars, the red world, named for its color, which comes from iron slowly rusting across its entire surface over billions of years. The reddish dust that gives Mars its color is, quite literally, an ancient and enormous version of the same rust you might see forming on an old nail left out in the rain. Except here, it covers an entire planet, drifting in wide, pale storms that can sometimes wrap around the whole globe for weeks at a time. There is something oddly gentle about imagining an entire world slowly and patiently rusting under a thin pink sky, with no rain heavy enough anymore to wash it away. But that is only one small part of the story. Mars was not always dry. Long ago, there were rivers there, wide, winding channels carved by flowing water, and lake beds that once held still, quiet water for who knows how long. Some of these ancient shorelines are still visible today, etched into the rock like a memory the planet never quite let go of. It's a strange kind of loss, imagining an entire world once soft with water that slowly dried into the silent red desert it is now. And yet, the shapes of those old rivers remain, patient traces of something that used to flow. Maybe there is comfort in that too, in knowing that even after everything changes, some quiet trace of what came before can still remain, gently written into the ground. There is something else worth resting on for a moment. Mars is home to Olympus Mons, the largest known volcano in the entire solar system, so wide that if you stood at its base, the slope would rise so gradually you might not even realize you were climbing a mountain at all. It is nearly 3 times the height of Earth's tallest mountain, yet its sides slope so gently that its true scale is almost impossible to feel while standing on it. Some of the largest things in the universe are like that, too vast to be felt all at once, only understood slowly, gently, in pieces. Let's drift outward now, past Mars, into a wide and scattered region called the asteroid belt. This belt is not, as some old stories imagined, the remains of a planet that was destroyed. It is instead the leftover material of a planet that never quite managed to form countless fragments of rock and metal, pulled and tugged in so many directions by nearby Jupiter's gravity that they could never settle into one whole world. There is something gentle in that idea too, an unfinished planet drifting quietly in pieces, not because something was broken, but because it simply never had the chance to become whole in the way the others did. But that is only one small part of the story. Within this scattered belt lies Ceres, the largest object there, round enough to be considered a dwarf planet in its own right. Beneath its dusty gray surface, scientists believe there may be pockets of water ice, and perhaps even a thin layer of salty liquid deep below. It's strange and quiet to imagine. A small, round world, drifting alone among fragments and rubble, possibly holding a hidden layer of water in its heart, unseen and unremarked upon for billions of years. Let's drift much farther out now, towards something enormous, Jupiter, the largest planet, so big that all the other planets combined could fit inside it with room to spare. Jupiter has no solid ground at all. If you tried to land on it, there would be nothing beneath you to stand on, only deeper and deeper layers of gas, thickening slowly into liquid, then finally into something strange and metallic near its core. It's an odd thing to imagine, an entire world with no floor, no surface, just endless depth folding downward into itself. There is something else worth resting on for a moment. On Jupiter's surface swirls a storm called the Great Red Spot, a storm so old that it has likely been raging without pause for at least a few hundred years, and possibly much longer. It is wide enough that Earth itself could fit inside it. Somewhere right now, that ancient storm is still turning, the same slow spiral it has held for centuries, utterly indifferent to anything happening down here. There's something almost restful about that, a storm so old and vast that it has outlived every single person who ever first noticed it. Let's rest for a while on one of Jupiter's smaller companions, Io, a moon covered in active volcanoes, more than any other body in the solar system. Io is stretched and squeezed by Jupiter's powerful gravity as it orbits over and over. And this constant flexing generates enormous heat deep inside it, heat that escapes through hundreds of volcanoes, painting its surface in shades of yellow, orange, and pale white, like a small world dipped in sulfur. It's a strange kind of restlessness, a moon that can never quite settle, endlessly reshaped by the pull of something far larger than itself. But that is only one small part of the story. Nearby drifts Europa, a moon wrapped entirely in a shell of ice. Beneath that frozen surface, scientists believe there may be a vast ocean, kept liquid by the same gravitational flexing that heats Io, an ocean hidden completely from sunlight, sealed away beneath miles of frozen crust. Somewhere out there, in complete darkness, that hidden ocean has been quietly sloshing for longer than any living thing has walked the earth, entirely unseen, entirely undisturbed. There is something else worth resting on for a moment. Ganymede, Jupiter's largest moon, is bigger than the planet Mercury, and it is the only moon in the solar system known to generate its own magnetic field. A small, quiet shield of its own, tucked deep within a giant planet's shadow. It's oddly comforting, imagining even a moon finding its own small way to protect itself, drifting steadily along in the company of something so much larger. Let's drift onward now, toward Saturn, the planet best known for its wide, glowing rings. Those rings are not solid, the way they might appear from a distance. They are made of countless individual pieces of ice and rock, ranging from tiny grains of dust to chunks the size of a house, all orbiting together in a wide, flat band that can stretch for hundreds of thousands of miles, while remaining, in places, only about as thick as a few dozen feet. It's strange to imagine something so vast and so thin at the same time, a delicate, glittering ring of countless separate fragments, each one following its own quiet path, together forming something that looks, from far away, perfectly smooth and whole. But that is only one small part of the story. Among Saturn's many moons is Titan, wrapped in a thick, hazy orange atmosphere, and home to lakes and rivers, not of water, but of liquid methane and ethane, pooling gently across its cold surface. It is the only moon in our solar system known to have stable liquid resting openly on its surface. Somewhere out there, beneath a dim orange sky, quiet methane rain falls slowly into cold lakes that have likely existed in some form for a very long time. There is something else worth resting on for a moment. Another moon, Enceladus, is far smaller, but hides something remarkable: geysers of water ice erupting from cracks near its southern pole, spraying fine icy mist out into space. Some of that mist even helps form one of Saturn's fainter rings. It's a gentle image in its own way, a small, icy moon quietly breathing out fine mist into the emptiness around it, patiently helping to build the very rings that circle its enormous neighbor. Let's drift farther still, toward Uranus, a pale blue-green world tilted almost completely on its side. No one is entirely certain why, but at some point in its ancient past, Uranus was likely struck by something massive enough to knock its entire spin off balance, leaving it rolling around the sun almost sideways, rather than upright like most of the other planets. Because of this strange tilt, each of its poles experiences roughly 42 years of continuous sunlight, followed by 42 years of continuous darkness, the longest, slowest seasons in the entire solar system. Imagine a single season lasting longer than most decades of a human life, an entire lifetime's worth of one unbroken sunrise or one unbroken night. But that is only one small part of the story. Uranus, too, has rings, though they are much fainter and darker than Saturn's, almost impossible to see without very careful searching. They went unnoticed by observers here on Earth for a very long time, quietly circling a sideways planet, unnoticed simply because no one had thought to look closely enough. There is something quietly moving in that. How much can exist, faint and patient, simply waiting for someone to finally notice it. Let's drift onward to Neptune, the farthest known planet, a deep and quiet blue. Neptune holds the strongest winds ever recorded on any planet in our solar system, gusting many times faster than the strongest hurricane ever measured here on Earth. And yet, from such a distance, it appears in our telescopes as nothing more than a still, calm, softly glowing point of blue light. It's strange to think of such fierce, roaring winds, utterly invisible from here, folded quietly into something that looks, from so far away, like nothing but stillness and calm. There is something else worth resting on for a moment. Neptune's largest moon, Triton, orbits backward compared to the planet's own spin. A strong hint that it wasn't born alongside Neptune at all, but was instead captured long ago from somewhere else entirely, pulled gently but permanently into a new and unfamiliar orbit. And despite the deep cold there, Triton has ice volcanoes, quietly venting nitrogen gas and dark, dusty material across its frozen surface, painting faint streaks across the ice. Somewhere out there, a moon that once belonged to a different story entirely now drifts quietly in Neptune's company, slowly making a new, cold home for itself. Let's drift even farther now, past Neptune, into a colder, dimmer region. Here lies Pluto, and a wide scattering of smaller icy worlds known as the Kuiper Belt. Pluto itself has mountains made of water ice, and a heart-shaped plain of frozen nitrogen so smooth that it appears to have been resurfaced again and again by slow-moving ice beneath. It's a gentle thought, a small, cold, distant world, quietly renewing its own surface over and over, in a place so far from the sun that daylight there is little more than a deep, dim twilight. But that is only one small part of the story. Beyond even the Kuiper Belt lies something vaster still, called the Oort cloud, a wide, spherical shell of icy fragments believed to surround our entire solar system, so distant that light from the sun would take more than a year to cross it. Almost nothing is directly seen there. It is simply believed to exist, quietly, patiently, holding the very outer edge of everything the sun still gently governs. There is something comforting in that, a boundary so far away, so quiet, that it barely feels real. And yet it is still, somehow, part of the same soft neighborhood we began in tonight. Let's rest for a moment on comets, small wanderers that sometimes drift in from that same distant cloud. A comet is, in a way, a kind of frozen time capsule, a small clump of ice, dust, and ancient rock, largely unchanged since the very early days of the solar system. When one drifts close enough to the sun, the ice on its surface begins to melt and stream away, forming the glowing tail we sometimes glimpse from Earth. It's strange and lovely, imagining a small piece of the solar system's original, ancient material, quietly preserved for billions of years, only now beginning to softly unravel as it passes near the light. Meteor showers, too, are gentler than they sound, simply the leftover dust trails of comets that passed through long ago, still drifting in the same old paths. When Earth quietly crosses through one of these trails each year, that dust burns softly in our atmosphere, and we see it as a brief, falling streak of light. Somewhere tonight, unseen dust from a comet that passed by centuries ago might be quietly drifting into our atmosphere, burning gently away, high above the clouds. Let's linger for a while on something quieter still, the geometry of eclipses. A solar eclipse only happens because of an extraordinary coincidence. The moon is about 400 times smaller than the sun, but it also happens to sit about 400 times closer to Earth. Because of this, the two appear almost exactly the same size in our sky, allowing the moon to pass directly in front of the sun and briefly darken the day. There is no particular reason this coincidence had to exist. It simply does quietly, allowing for a few rare, dim moments where day briefly folds into a soft twilight and then unfolds again. It's a small, strange gift, this coincidence, one small alignment among countless others, quietly making something rare and beautiful possible. Let's drift back now, gently, toward the very beginning of all of this. Long before any of these planets existed, there was only a vast, slowly spinning cloud of gas and dust, drifting quietly in the dark. Over an unimaginably long stretch of time, gravity gently pulled that cloud inward, flattening it into a wide spinning disk. At its center, the material grew dense enough to ignite, becoming our sun. Everything else, every planet, moon, and drifting fragment we've wandered through tonight, slowly gathered itself together from the leftover material circling that new, young star. So everything in this quiet neighborhood, including the ground beneath you right now, was once part of the very same slow, spinning cloud. There is something else worth resting on for a moment. Far beyond even the Oort cloud, two small, human-made objects called Voyager 1 and Voyager 2 are still drifting outward, carrying golden records etched with sounds and images of Earth. Just in case anything, someday, somewhere, finds them. They have already passed beyond the outer edge of the sun's influence, into the quiet space between stars, and they will likely continue drifting long after every living thing on Earth today has gone. It's a strange and gentle thought. Two small, quiet travelers carrying a soft record of us, drifting on and on through the dark, long after we're gone. Simply because, once, someone wanted to leave a small trace behind. There is something else worth resting on for a moment. None of this, not a single planet, not a single ring, not a single distant moon, would hold together at all without gravity. An invisible, patient force, quietly keeping everything in its gentle, curved path. You never see gravity directly. You only see its effects. An apple falling, a moon orbiting, a whole solar system quietly turning, held together by something you can feel but never touch. Maybe that's true of a lot of the softest, steadiest things. Unseen, but always quietly holding everything gently in place. Let's rest now on the stars beyond our own. Every star you might glimpse tonight, if you were to look up, sends light that began its journey long before it ever reached you. Some of it years old, some of it centuries old, some of it far older still. Our own sun is just one such star among billions, quietly warming this one small neighborhood, while countless other stars quietly warm neighborhoods of their own, scattered across the dark. There is something small and settling in that, realizing how many quiet, warm centers there might be, each one slowly, patiently doing the same gentle work ours has been doing for you your whole life. Let's linger, finally, on the very edge of everything we've wandered through tonight, far out past every planet, past the Kuiper Belt, past even the Oort cloud. There is a wide, invisible boundary called the heliosphere, the outer limit of the sun's gentle influence, where its solar wind finally fades and gives way to the quiet space between stars. Beyond that edge, the sun no longer reaches, and yet everything inside it, every planet, every moon, every small drifting fragment we've wandered past tonight, has been quietly held gently inside that one soft boundary for billions of years. You are inside that boundary too, right now, resting quietly, held gently inside the same soft edge that has sheltered this whole small neighborhood since before there was ever anyone here to notice. Let's rest for a moment on the sky above you and why it wears the color it does. Sunlight looks white, but it's really made of every color woven together. As that light passes through our atmosphere, the shorter, bluer wavelengths scatter more easily off the tiny molecules of air, spreading across the whole sky, while the other colors mostly pass straight through. That's why the sky above you looks blue during the day, and why it softens into orange and rose at sunset, when the light has to travel through so much more air to reach you. So the color of the sky isn't really a color the sky has. It's something light does quietly every day as it passes through the same air you're breathing right now. There is something else worth resting on for a moment. The moon's gravity doesn't just pull gently on rock and dust. It pulls on the oceans too, gathering the water on Earth's near side, and even the water on the far side, into two low, wide bulges that slowly follow the moon as it circles us. As the Earth spins beneath those bulges, we feel them arrive as the rising and falling tide. Somewhere on a coastline right now, water is quietly rising or falling, nudged by a moon hundreds of thousands of miles away, in a rhythm that is repeated twice a day, for longer than any shoreline has had a name. But that is only one small part of the story. Earth doesn't spin perfectly upright. It leans, tilted about 23 degrees to one side, and that gentle lean is the entire reason we have seasons at all. As Earth travels around the sun, first one hemisphere, and then the other leans a little closer to the light, bringing longer days and warmer months, then longer nights and cooler ones. The seasons were never caused by moving closer to or farther from the sun. They were only ever caused by this one soft, permanent tilt, quietly carried through every single orbit since the planet first began to spin. There is something else worth resting on for a moment. Sometimes, the sun releases sudden bursts of energy called solar flares, and occasionally, enormous clouds of charged particles called coronal mass ejections, which drift outward and can reach Earth a day or two later. Most of the time, our magnetic field simply absorbs them quietly, giving us nothing more than a wider, brighter aurora than usual. It's a strange comfort, knowing that even a star's most sudden outbursts usually arrive here gently, softened by distance and by the quiet shield around us, into nothing more dramatic than a slightly brighter night sky. Let's drift back toward the sun's own skin for a moment and rest on sunspots. Sunspots are dark, cooler patches that appear on the sun's surface where its magnetic field grows especially tangled. Even though they look dark against the brightness around them, a single sunspot could still easily swallow the entire Earth many times over. It only looks small and dim because everything around it is so much brighter still. There's something almost tender in that. The darkest, coolest place on the sun's whole surface is still far hotter and brighter than anything we could ever stand near. And yet from here, it looks like nothing more than a small, quiet freckle. Let's linger a little longer near Jupiter, on something easy to miss. Jupiter has rings too, though they are so faint and thin, made mostly of fine dust, that they went completely unnoticed for a very long time, hidden in the glare of a planet so much brighter and busier to look at. Jupiter also has more moons than any planet needs, dozens upon dozens of them, some no larger than a small town, quietly circling far out at the edges of its enormous gravity, barely ever named or noticed at all. It's a gentle thing to imagine a whole quiet crowd of small, unremarkable moons, content simply to orbit, unnoticed, in the shadow of something enormous. There is something else worth resting on for a moment. When Galileo first turned a simple telescope toward Jupiter centuries ago, he noticed 4 small points of light drifting alongside it, changing position from night to night. He had found its 4 largest moons, Io, Europa, Ganymede, and Callisto. The first moons ever discovered around a planet other than our own. It's a quiet thing to picture. One person, one small telescope, one ordinary night, noticing 4 faint points of light that would end up changing how everyone understood the sky. Let's rest for a while near Saturn again, on something almost playful. Saturn is the least dense of all the planets, so light, in fact, that if you could somehow find an ocean vast enough to hold it, Saturn would actually float. It is made mostly of light gases, held together loosely by its own gravity, rather than the dense rock and metal that make up worlds like ours. There's something soft in that thought. The second largest planet in our entire solar system, and yet, in its own strange way, lighter than water. There is something else worth resting on for a moment. At Saturn's North Pole sits a strange, six-sided storm pattern, wide enough to fit several Earths inside it. Its straight edges holding steady for as long as we've been able to watch it. No one fully understands why it takes this shape rather than a simple, rounded swirl. It's a strange, quiet mystery tucked at the very top of a giant planet. A storm that somehow prefers straight lines, patiently keeping its shape for years at a time, for reasons still not entirely understood. Let's linger a little longer among Saturn's smaller moons. One of them, Mimas, carries an enormous crater on one side, so wide and so deep that it gives the whole moon a strange, familiar look to anyone who has seen certain old space films. Round, gray, and quietly marked by one single, dramatic scar from some impact long ago. It survived that collision somehow and simply kept orbiting, carrying that old wound quietly around Saturn ever since. The same slow path, over and over, for longer than anyone has been alive to notice. There is something else worth resting on for a moment. Another of Saturn's moons, Ipetus, is oddly two-toned, one hemisphere pale and icy, the other dark as coal, as though someone had drawn a careful line straight down its middle. The likely cause is dark dust from a nearby moon, slowly settling onto one side over a very long time, while the far side stayed bright and untouched. It's a gentle image in its way, a small moon, quietly divided between light and dark, simply from drifting for ages through the same patient dust. Let's drift back toward Uranus for a moment, on something small and steep. One of its moons, Miranda, holds a canyon so deep that in places it drops many times farther than the Grand Canyon here on Earth. Its icy surface looks patched together, oddly, as though pieces of a much larger, shattered world had been gently reassembled long ago. There's something quietly hopeful in that idea, something that may once have broken apart, slowly gathering itself back together into a single, whole, if slightly uneven, small world. There is something else worth resting on for a moment. Neptune was never first spotted by a telescope sweeping the sky. It was found on paper first. Mathematicians noticed that Uranus's orbit kept wobbling slightly, as though something unseen were tugging at it. They calculated where that hidden pull must be coming from, and when astronomers finally pointed a telescope to that exact patch of sky, Neptune was waiting there, almost exactly where the numbers had said it would be. It's a strange, quiet kind of discovery. A whole planet found first in the patient shape of an equation, long before anyone ever laid eyes on it. Let's rest for a while near the very edge of the known planets, on Pluto's closest companion. Pluto's largest moon, Charon, is so close in size to Pluto itself that the two don't quite orbit the usual way. One large body with a much smaller one circling it. Instead, they slowly turn around a shared point of balance between them, almost like two dancers holding hands and spinning slowly together in the dark. Both worlds are also tidally locked to each other, meaning each always shows the very same face to the other, forever, the way an old, quiet friendship might settle into always facing the same way. There is something else worth resting on for a moment. Farther out in the Kuiper Belt drifts a small, ancient world nicknamed for its shape. Two lobes gently joined together, like a snowman, drifting slowly through the dark. It is one of the most distant objects ever visited up close, and its gentle, undisturbed shape suggests it has barely changed since the solar system's earliest days. It's a soft thought to hold, something so far away, so rarely visited, quietly keeping the same shape it settled into billions of years ago, patient and untouched. Let's drift back toward Mars for one more quiet moment on its two small moons. Phobos and Deimos are tiny, oddly shaped moons, likely captured asteroids rather than moons born alongside their planet. Phobos circles so closely and quickly that it orbits Mars several times in a single Martian day, and it is slowly spiraling inward, so gradually that it may eventually break apart or drift down onto the surface it has circled for so long. There's something gentle in imagining a small, borrowed moon, spending ages quietly circling a planet it was never originally part of, simply because gravity happened to catch it passing by. There is something else worth resting on for a moment. Mars also has polar ice caps, layered with both frozen water and frozen carbon dioxide, that grow and shrink with its seasons, much like snow does here, only far colder and far slower to change. Somewhere on that distant red world right now, a quiet cap of ice is either slowly widening or slowly retreating, following the same unhurried rhythm it has followed for ages. Let's rest for a while on something almost too faint to notice. If you were far from any city lights, on a very dark, clear night, you might glimpse a soft, pale band of light rising from the horizon, easy to mistake for a stray patch of cloud. This is called zodiacal light, sunlight, gently reflecting off countless tiny grains of dust scattered thinly along the same flat plane where all the planets orbit. That dust has likely been drifting there since the solar system's earliest days, patiently reflecting a soft glow that only the darkest nights ever reveal. There is something else worth resting on for a moment. The entire asteroid belt, despite being scattered across such a wide stretch of space, holds less total material than our own moon. It only seems vast because it is spread so thin across such an enormous distance rather than gathered closely together. It's a gentle reminder that something can feel enormous simply because of how far it's spread out, even while gathered together. It might be smaller than you'd ever guess. There is something else worth resting on for a moment. Not all asteroids drift freely through the belt. Some, called Trojans, quietly share Jupiter's own orbit, resting in two calm gravitational pockets ahead of and behind the giant planet, held there gently by the same balance of forces, drifting along at exactly the same pace, forever a patient step ahead or behind. There's something soothing in that image. Countless small companions, simply keeping pace, never rushing to catch up, never falling behind, content to travel the same quiet path forever. Let's rest, finally, on something larger than any single planet or moon. Our entire solar system, sun and all, is itself slowly orbiting the center of the Milky Way galaxy, carried along at a tremendous but utterly imperceptible speed. It takes roughly 230 million years to complete just one full loop, meaning the sun has only completed a small handful of these loops since it first began to shine. Everything we've wandered through tonight, every planet, every moon, every quiet ring of ice, is also quietly riding along on that same unimaginably slow, wide, patient orbit, and has been the entire time, without you ever needing to feel it moving at all. Let's rest for a moment on something you can only see during the rarest kind of daylight. Beyond the sun's bright surface lies its corona, a wide, faint halo of gas stretching out for millions of miles, far hotter, strangely, than the surface it surrounds. It is normally lost in the glare of ordinary daylight and only becomes visible during a total solar eclipse, when the moon briefly covers the sun's face and reveals that pale, silvery crown glowing quietly around the dark circle where the sun used to be. It's a soft thought. Something has been glowing out there this whole time, wrapped gently around our star, hidden only because everything nearer to us has always been too bright to let us notice it. There is something else worth resting on for a moment. Long before any of the planets had settled into their steady orbits, the young disk of dust and gas surrounding our new sun was a much rougher, busier place. Countless small clumps, called planetesimals, drifted and collided, sometimes shattering apart, sometimes merging gently together, slowly building larger and larger bodies over millions of years. Every planet we've wandered through tonight was once nothing more than one of these small, patient collisions, repeated again and again, until very slowly, it became whole. Let's return to our own planet for a while and rest on something deep beneath your feet. Earth's very center holds a solid inner core of iron and nickel, even though the temperature there rivals the surface of the sun. It stays solid only because of the immense pressure pressing in on it from every side, holding its atoms in place despite heat that would easily melt iron almost anywhere else. There's something quietly reassuring in that, something so deeply pressed upon that, rather than breaking apart. It simply holds steady, unmoving, at the very heart of everything. There's something else worth resting on for a moment. Earth is also the only rocky planet we know of with a surface broken into large, slowly shifting plates, drifting gently over the softer rock beneath them across millions of years. These plates are why we have mountain ranges and ocean trenches and the gentle, gradual reshaping of coastlines that never quite stops, even though it moves too slowly for any of us to ever notice happening. The ground beneath you tonight has been quietly drifting your entire life, and the life of everyone before you, moving only a few inches a year, patient beyond anything a single lifetime could measure. Let's drift back to Venus one more time on something gentler than its heat. Some scientists believe Venus may once have had oceans of its own long ago, before a runaway greenhouse effect slowly boiled them away and left behind the thick, scorching atmosphere it wears today. True, Venus may have once been a much softer, calmer place than the world we see now. It's a quiet kind of sadness and a quiet kind of wonder together. A whole ocean lost slowly over ages, leaving behind only a memory written into the chemistry of its clouds. There's something else worth resting on for a moment. Despite being the closest planet to the sun, Mercury holds patches of water ice, tucked away in permanently shadowed craters near its poles, where sunlight never quite reaches. In the coldest, darkest corners of the hottest neighborhood in our solar system, a small, quiet frost has been resting, undisturbed, for a very long time. It's a soft contradiction to hold on to. Somewhere, even in the harshest, most sun-baked little world we have, a small patch of quiet cold has managed to survive. Let's rest again near Jupiter, on something slowly fading. The great red spot has been shrinking gradually over the past century or so, growing narrower with each passing decade. No one is entirely sure whether it will fade away completely someday, or simply settle into some smaller, steadier size and continue on. Even a storm old enough to have outlived centuries of quiet watching may still, slowly, be changing shape, the way almost everything eventually does, given enough time. There is something else worth resting on for a moment. Jupiter also produces powerful auroras of its own, glowing steadily near its poles, driven partly by its own enormous magnetic field, and partly by material spewed out from the volcanic moon Io nearby. These auroras shine far brighter and more constantly than our own gentle, occasional ones here on Earth. Somewhere out there, a giant, quiet planet is wearing its own steady crown of light, glowing softly above its poles, mostly unseen by anyone at all. Let's drift back to Saturn's rings once more, on something a little wistful. Scientists believe Saturn's rings may not be nearly as old as the planet itself, and that they are also very slowly raining down onto Saturn, drawn in gently by its gravity and magnetic field. Some estimates suggest the rings could fully disappear within the next 100 million years or so, a blink. By the standards of the solar system's whole life so far, it's a gentle kind of impermanence. Even something as grand and steady as Saturn's rings will, eventually, softly settle into the planet they've circled for so long. There is something else worth resting on for a moment. Titan's atmosphere is thick enough, and its gravity light enough, that if a person stood there in the right protection, they could likely glide through its skies simply by flapping a pair of wide, wing-like attachments, almost like flying under their own effort. It is one of the very few places in our solar system where something like true human flight might actually be possible. There's something almost dreamlike in that thought. A distant orange moon, cold and hazy, where the air itself might be gentle enough to hold you aloft. Let's rest for a while on Callisto, one of Jupiter's quieter moons. Callisto's surface is heavily cratered, more so than almost anywhere else nearby, because unlike some of its neighbors, it has had very little internal activity to smooth or renew itself. Its face has simply gathered impacts quietly for billions of years, keeping nearly every mark it has ever received. It's a patient kind of moon, holding onto every old scar rather than smoothing them away. A long, unhurried record of everything that has ever happened to touch it. There is something else worth resting on for a moment. Despite Uranus sitting farther from the sun than Saturn, Neptune actually holds the record for the coldest measured temperatures among the planets, in the high, thin clouds drifting near the top of its atmosphere. Being farther from the sun doesn't always mean being colder. Sometimes it depends more on what a planet is made of and how it holds or releases its own inner heat. It's a gentle reminder that distance alone doesn't tell the whole story. Sometimes what's underneath, quietly held or quietly released, matters more than how far away something sits. Let's rest for a moment on Neptune's own passing storms. Astronomers once spotted a large, dark storm on Neptune, nicknamed a great dark spot, only to watch it fade away entirely within a few years. And other, smaller dark storms have appeared and vanished since. Unlike Jupiter's ancient, long-lived storm, Neptunes seem to drift into being and then quietly dissolve again without ever settling permanently. There's something soothing in that difference. Not every storm has to last centuries. Some are simply allowed to pass through gently and then let go. Let's drift very far out now, past Pluto, on some of its quieter cousins. Beyond Pluto drift other small, icy dwarf planets. Eris, nearly as large as Pluto itself, and drifting even farther out. Haumea, spinning so quickly that it has been stretched into an oddly elongated shape, like a small egg tumbling slowly through the dark. And Makemake, distant and dim, discovered only in recent years, quietly circling far from any warmth at all. Somewhere out there, an entire small family of icy, half-forgotten worlds drifts along together, far from any spotlight, simply continuing their slow, patient orbits. There is something else worth resting on for a moment. Even farther out than these lies Sedna, one of the most distant known objects in our solar system, on an orbit so wide and so stretched that it takes more than 11,000 years just to complete a single loop around the sun. It is, for most of that unimaginable journey, utterly alone in the dark, farther from any warmth than almost anything else we know of. It's a strange, quiet thing to hold, a single small world, on a path so long that it will still be slowly returning home long after every memory of tonight has faded into something else entirely. Let's rest for a while on a visitor from somewhere else entirely. A few years ago, astronomers spotted something unusual passing quickly through our solar system. A strange, elongated object that didn't belong to us at all, but had drifted in from somewhere among the distant stars, curved briefly past the sun, and then continued on its way, out into the dark again, never to return. It's a gentle, curious thought that every so often, something from an entirely different corner of the galaxy might quietly pass through this same small neighborhood, pause here only briefly, and then simply keep going. There's something else worth resting on for a moment. Our entire solar system is currently drifting through a faint, thin patch of interstellar gas and dust, sometimes called the local fluff, part of a much larger cloud scattered through this region of the galaxy. The sun's own quiet magnetic bubble gently pushes most of it aside as we pass through, shielding the planets much the way Earth's own field shields us. Somewhere unseen, this whole neighborhood is quietly drifting through faint cosmic mist, gently nudged aside by a bubble of solar wind that has been holding it back for as long as the sun has shone. Let's rest for a moment on why the planets don't simply drift off in straight lines. Every planet moves a little faster when it swings closer to the sun, and a little slower when it drifts farther away, tracing not a perfect circle, but a gentle, stretched oval path called an ellipse. This quiet rule was noticed centuries ago, simply by patiently watching the sky and writing down, very carefully, exactly how the planets seem to wander. There's something soft in imagining that pattern, a whole solar system, gently speeding and slowing, in a rhythm as steady and unconscious as a heartbeat. There is something else worth resting on for a moment. Not every asteroid is simply stone. One named Psyche, drifting quietly in the asteroid belt, appears to be made largely of metal, nickel, and iron, likely the leftover core of a much larger world that lost the rest of itself to ancient collisions long ago. It's a quiet, strange kind of survival, the innermost heart of some larger, shattered world, still drifting on alone, having outlasted everything that used to surround it. Let's rest one more time on a very old and very patient visitor. Halley's Comet has been returning to swing past the sun roughly every 76 years, for as long as records have been kept. Its glowing tail briefly gracing our sky before it drifts back out into darkness, not to be seen again until long after most who watched it are gone. It is, in its own way, a slow and steady rhythm, wider than a single lifetime, quietly repeating itself over and over, long before you were born, and long after you'll have forgotten this very night. Let's rest for a moment on the way the sun spins unevenly upon itself. Because the sun is not solid, its different regions are free to rotate at different speeds, its equator completing a full turn in about 25 days, while its poles take closer to 35. No solid world could ever twist like that without tearing itself apart. But the sun, being made of gas and light, simply allows each part of itself to move at its own gentle pace. There's something quietly freeing in that image. A whole star, content to let different parts of itself move differently, without ever needing to force them into matching one another. There's something else worth resting on for a moment, far off in a future so distant it barely needs to be feared at all. Billions of years from now, long after anything alive today could possibly still be here, the sun will slowly swell into what's called a red giant, its outer layers stretching outward until they likely reach past Mercury, and perhaps past Venus as well. It is an ending so far away in time that it belongs less to worry, and more to a strange, distant kind of wonder. A reminder that even a star story unfolds slowly, gently, across almost unimaginable stretches of time. You don't have to hold that thought tightly either. It's simply there, quiet and distant, like a far horizon you'll never actually have to walk to. Let's rest again on our own small blue world and why it alone seems to hold life. Earth sits inside what's sometimes called a habitable zone, a narrow, gentle band of distance from the sun, neither so close that water boils away, nor so far that it freezes solid. Within that narrow band, and with the right mixture of atmosphere, magnetic shielding, and a bit of good fortune, liquid water has been able to rest quietly on the surface for billions of years, patient enough for life to slowly take hold. It's a soft thing to realize how many gentle conditions had to align quietly all at once, simply to make a place soft enough for you to be resting here tonight. There is something else worth resting on for a moment. Our atmosphere doesn't just let us breathe. It also quietly protects us from countless tiny fragments of rock and dust falling from space, burning up harmlessly, high overhead, before they ever reach the ground. Every single day, without you ever noticing, small pieces of ancient debris are gently disintegrating above you, turned to nothing more than a faint streak of light too faint to see. Somewhere above you right now, in complete silence, tiny old fragments of space are quietly burning away, protecting you from something you never even knew was falling. Let's rest for a while on the far side of the moon. The moon is tidally locked to Earth, always showing us the very same familiar face, which means an entire other side exists that no human being had ever seen with their own eyes, until spacecraft finally drifted around and photographed it. That far side looks surprisingly different, rougher, more heavily cratered, with far fewer of the smooth, dark plains that mark the face we know so well. It's a strange, quiet thought, something so close, so familiar, so endlessly gazed upon, and yet it has, this whole time, kept one entire half of itself turned gently away, unseen, simply because of how it happened to settle into its orbit. There is something else worth resting on for a moment. On Mars, thin winds occasionally gather into towering dust devils, slender spinning columns that can rise many times taller than any similar whirlwind here on Earth, moving quietly across the reddish plains before dissolving again into stillness. And because Mars's atmosphere is so thin, sound itself behaves differently there, traveling more quietly, more slowly, and fading faster than it would in our own thicker air. A whole world existing in a hush deeper than almost anywhere you could stand on Earth. Let's rest for a moment back at Ceres, on something bright and unexpected. Within one of Ceres's largest craters lie strange, bright spots, far paler than the dusty gray surface surrounding them. These turned out to be deposits of salt, likely left behind as briny water, pushed up from somewhere below, slowly evaporated away on the surface, leaving only its pale mineral trace behind. It's a gentle little mystery, hidden in a small, round world, a quiet reminder that something can leave a bright, lasting mark long after whatever carried it there has gone. There is something else worth resting on for a moment. Some of Saturn's smaller moons drift directly within gaps in its rings, gently clearing a path through the ice and dust as they pass, almost like small shepherds guiding their surroundings into place. Because of the ring material gathering onto them as they orbit, a few of these little moons have taken on strange, flattened shapes, wide and thin, almost like a small dumpling or a flying disk drifting quietly along its own narrow lane. There's something almost playful in that image. Tiny, oddly shaped moons, patiently tending the very rings they were shaped by, going around and around in their same narrow gap. Let's rest for a while on how Uranus first came to be known at all. Uranus was the first planet ever discovered using a telescope rather than simply the naked eye. Spotted quietly by an astronomer scanning the sky one ordinary night, who at first assumed it was only a faint, unfamiliar star, or perhaps a comet. Only after careful, patient observation did it reveal itself to be something new entirely. A planet no one before had ever known was there. It's a gentle thought to hold. An entire planet, hiding in plain sight in the night sky for as long as anyone had been watching, simply waiting for someone patient enough to look closely. There is something else worth resting on for a moment. Neptune's rings, unlike Saturn's smooth, wide bands, are thin, faint, and strangely clumped in places, gathered into denser arcs rather than spread evenly all the way around. No one is entirely sure why the material prefers to bunch together this way, rather than spreading out evenly, though the gentle gravity of nearby moons is thought to nudge it gently into place. Even something as simple as a ring, it seems, doesn't always have to be even and smooth to still quietly hold its shape. Let's rest for a moment on where comets seem to come from and what pulls them near. Comets with shorter, more frequent orbits tend to drift in from the Kuiper belt, nudged inward now, and then by the gentle pull of the outer planets, while comets on much longer, rarer paths, sometimes taking thousands of years to return even once, are thought to originate from the far more distant Oort cloud. Either way, each comet is simply drifting along an old, familiar path, occasionally swinging close enough to glow before retreating back into the quiet dark it came from. And when a comet does pass near the sun, it often grows two separate tails, rather than one made of dust, curving gently along the comet's path, and another made of ionized gas, pointing directly away from the sun, both simply following the quiet pressure of sunlight and solar wind pressing softly against them as they pass. There is something else worth resting on for a moment. Nearly all of the planets orbit the sun along roughly the same flat, invisible plane, called the ecliptic, rather than scattering off in every direction. This is simply a leftover memory of the wide, flat, spinning disk of gas and dust that gathered together to form them all in the first place, billions of years ago. That's part of why, from here on Earth, the planets always seem to travel along roughly the same narrow path across our sky, night after night, quietly tracing the same old, flattened shape their birth once gave them. Let's rest, finally, on how small a space all of this really occupies. If the sun were shrunk down to the size of a basketball, Earth would be smaller than a small pea, drifting quietly about 30 yards away. And Neptune, the farthest planet, would still be resting less than a third of a mile off. The entire wide, wandering neighborhood we've spent tonight exploring, folded down into something you could walk across in a few quiet minutes. Everything we've wandered through tonight, every moon, every ring, every ancient, patient storm, has always been resting together in a space far smaller and far quieter than it ever feels from here. Let's rest for a moment on a quiet pattern hidden within the asteroid belt. Scattered through the belt are narrow, empty lanes called Kirkwood gaps, places almost entirely swept clean of asteroids. These gaps exist because any rock drifting into them would be pulled again and again by Jupiter's gravity at just the wrong, repeating moments, slowly nudged away until the space empties out and stays that way. It's a gentle kind of order, hidden inside what looks like scattered chaos. Certain paths simply becoming too unsteady to rest in, until, over time, they empty themselves out into quiet, permanent gaps. There's something else worth resting on for a moment. Threading through the space between the planets is something called the heliospheric current sheet, a wide, wavy, invisible boundary within the sun's magnetic field, rippling outward like the edge of a slowly twirling skirt as the sun rotates. Every planet, including Earth, drifts in and out of it as it orbits, crossing that quiet, folding boundary without ever feeling a thing. There's something soft in imagining a vast, unseen ripple, gently wrapped around the whole solar system, patiently turning in place while everything else orbits calmly through it. Let's rest for a while on how ancient people first learned to read the sky. Long before telescopes, people noticed that certain stars seemed to wander slowly against the fixed backdrop of the others, tracing the same narrow band across the sky, year after year. They marked that band with familiar shapes, the same constellations still traced today, using them quietly to track seasons, plan harvests, and mark the passing of long, unhurried years. It's a gentle thought, imagining someone, centuries ago, lying back much like you are now, watching the same quiet band of stars drift overhead and finding their own soft comfort in it. There is something else worth resting on for a moment. Beneath Ganymede's icy, cratered shell, much like its neighbor Europa, scientists believe there may rest another hidden layer of salty water, sealed away far beneath the frozen surface. Two quiet moons, side by side in the same neighborhood, may each be softly guarding their own hidden ocean, unseen by any sunlight at all. Somewhere in that sealed darkness, water may be resting quietly, exactly the way it has for longer than anyone could easily imagine. Let's rest for a moment on Europa's strange, cracked surface. Europa's icy shell is covered in long, crisscrossing lines and jumbled patches nicknamed chaos terrain, places where the ice appears to have broken apart and refrozen unevenly, hinting at slow movement happening somewhere beneath the frozen crust. It is one of the clearest outward signs that something is quietly shifting deep below that still, pale surface. It's a soft thought to hold, a whole moon wearing the quiet cracks of something moving gently beneath it, the way a still pond sometimes shows the faintest ripple from something passing far below. There is something else worth resting on for a moment. Even tiny, sun-baked Mercury carries its own faint magnetic field, generated deep within a core surprisingly large for such a small world. No one fully expected so small a planet to still be generating any magnetism at all. And yet, quietly, it does. There's something reassuring in that. Even the smallest, most exposed little world in our neighborhood still manages to carry its own small, invisible shield. Let's rest for a while on something unexpected happening inside Venus's clouds. Spacecraft passing near Venus have detected signs of lightning flickering within its thick, restless clouds. Brief and sudden flashes deep inside that heavy, acidic atmosphere. Even a world wrapped so tightly in heat and haze still finds room, now and then, for a sudden brief spark of light. It's a strange, quiet contrast. A slow, smothering, unmoving heat, occasionally interrupted by something as fast and sudden as lightning, deep within its clouds. There is something else worth resting on for a moment. High above Earth, two wide, donut-shaped regions called the Van Allen belts quietly trap charged particles, held gently in place by our planet's magnetic field, encircling us at a safe distance above the atmosphere. They are, in their own way, another soft layer of the same quiet shielding that has been protecting this small, blue world the whole time. Somewhere above you right now, invisible and silent, these wide bands are simply doing what they've always done, holding certain particles gently at bay, so very far above where you are resting. Let's rest for a moment on Titan's quiet, dark dunes. Beneath its thick orange haze, Titan holds vast fields of dunes, not made of ordinary sand, but of fine, dark, solid hydrocarbon grains, shaped slowly by winds into long, rippling rows across its cold plains. It is one of the only other places we know of with something resembling a desert, though though nothing about it would feel warm or familiar if you ever stood there. It's an odd, gentle image, an entire moon, softly wrinkled with dunes, quietly reshaped by winds under a sky the color of a dim, endless dusk. There is something else worth resting on for a moment. More than once, astronomers have spotted small, fast-moving objects passing briefly through our solar system that clearly came from somewhere else entirely, drifting in from between the stars, curving once around the sun, and continuing back out into the dark, never slowing down enough to stay. It's a quiet, curious thought that every so often, this small, familiar neighborhood receives a brief, wandering visitor from somewhere unimaginably far away, who pauses only a little while before continuing on, alone, into the dark. Let's rest one more time on how much of everything here truly belongs to the sun. The sun holds more than 99% of all the mass in our entire solar system. So much that every planet, moon, asteroid, comet, and drifting fragment we've wandered through tonight, combined, still barely amounts to a small remainder, circling one enormous, quiet center. Everything we've explored tonight, however vast or strange it seemed, was only ever a small, gentle orbit away from one single, patient source of light and warmth. The same warmth that has been resting quietly over you in one soft form or another this entire time. Let's rest for a moment on the quiet, protective role Jupiter seems to play for everyone else. Because Jupiter is so enormous, its gravity gently pulls at passing comets and asteroids, sometimes flinging them away entirely, and sometimes drawing them in to collide with its own thick clouds, instead of continuing farther inward, toward the smaller, more fragile planets nearer the sun. Some scientists think of it as a kind of quiet, oversized guardian, patiently absorbing far more than its fair share of stray impacts. There's something comforting in imagining a giant, silent presence out there, gently gathering in danger before it ever has the chance to drift any closer to home. There is something else worth resting on for a moment. The sun's magnetic field doesn't stay the same forever. Roughly every 11 years, it slowly flips, its north and south gently trading places in a long, unhurried cycle that also rises and falls in step with how many sunspots and flares appear along the way. It's a strange, patient rhythm, an entire star quietly reversing its own magnetic compass every decade or so, over and over. The way some things simply need to turn themselves inside out every so often in order to keep going. Let's rest for a while on a very slow wobble in our own planet's spin. Earth doesn't just tilt, it also wobbles, ever so slightly, tracing a slow circle with its axis over about 26,000 years. Because of this, the particular star that currently sits above our North Pole, the one we call the North Star, hasn't always held that position and won't forever. Long ago, a different star marked true north, and one day, gently, another will again. Even something as steady as north has only been resting where it is for a while, quietly drifting on to somewhere else across a timescale far too slow for any one life to notice. There is something else worth resting on for a moment. That same wobble is kept remarkably gentle and steady thanks, in part, to the quiet, stabilizing pull of our moon's gravity. Without a companion of roughly that size nearby, Earth's tilt might wander far more wildly over long stretches of time, shifting the seasons into something far less steady than what we've always known. It's a soft thing to consider. The same moon that quietly pulls our tides has also, this whole time, been gently helping to hold our seasons steady, simply by resting nearby. Let's rest for a moment on a quiet disagreement among astronomers. For a long time, Pluto was counted among the planets, until a clearer definition of the word eventually placed it instead among a newer category called dwarf planets, alongside Eris, Haumea, Makemake, and Ceres. Pluto itself never changed. It simply kept doing exactly what it had always done, drifting patiently along its same wide, icy orbit, indifferent to whatever word we eventually chose to describe it. There's something quietly settling in that. Some things continue on exactly as they always have, resting comfortably in themselves, no matter what name we eventually give them. There's something else worth resting on for a moment before we let this all go completely. On Mars, sunsets glow with a soft, pale blue near the sun itself, the very opposite of the warm gold and rose we're used to here on Earth. It happens because fine reddish dust in its thin atmosphere scatters light differently than our own air does, gently reversing the colors we've always taken for granted at the end of a day. Somewhere right now, beneath a dim, dusty pink sky, a small blue glow might be quietly settling around a distant sun, on a world where even something as familiar as a sunset wears an entirely different color. Let's rest just a little longer on how many quiet fragments actually drift through the asteroid belt. Millions of individual asteroids are believed to circle within that wide band between Mars and Jupiter, ranging from specks of dust to bodies hundreds of miles across, each one following its own slow, separate path. And yet, spread across such an enormous stretch of space, spacecraft can usually pass through the entire belt without ever coming close to a single one. It's a gentle kind of vastness, millions of quiet travelers, and still room enough between them for almost complete, empty silence. There's something else worth resting on for a moment. Very early in the solar system's history, during a stretch sometimes called the Late Heavy Bombardment, many worlds, including our own moon, endured a period of especially frequent impacts, leaving behind the wide, overlapping craters still visible on the moon's surface today. That rough, chaotic chapter eventually settled slowly into the much calmer, quieter neighborhood we've been wandering through tonight. It's a soft thing to remember as we near the end of our journey. Even the roughest, most chaotic beginnings can settle, given enough patient time, into something calm enough to rest inside of. Let's rest one final time on simply how far light has had to travel to reach you all night long. Sunlight takes a little over 8 minutes to reach Earth, about 40 minutes to reach Jupiter, and well over 4 hours to finally reach Neptune, drifting outward the entire time, growing fainter and fainter, but never entirely stopping. Every quiet planet and moon we've wandered through tonight has simply been waiting patiently for its own small share of that same light to arrive. And now, so gently, so slowly, this same unhurried evening is finally arriving at its own quiet end too. The way light always eventually does, not rushing, not hurrying, just softly, patiently arriving. Let's rest for one more quiet moment on something bright that occasionally streaks past, far brighter than an ordinary shooting star. Every so often, a larger fragment of rock enters our atmosphere and burns so brightly, so briefly, that it's given its own name, a fireball, or a bolide, flaring for a second or two, sometimes bright enough to cast quick shadows before vanishing completely into the dark again. Almost always, whatever remains simply turns to fine dust long before it could ever reach the ground. Somewhere above you, on some quiet night you'll never happen to be watching, one of these brief, bright fragments might streak silently overhead and vanish again, its whole brief story beginning and ending before anyone even has time to point it out. There is something else worth resting on for a moment, gentler still. Sound doesn't travel through the empty space between the planets at all. There's nothing there for it to move through. Every collision, every solar flare, every quiet storm we've wandered past tonight has happened in complete and total silence, no matter how violent or vast it may have looked. All of the sound belongs only to worlds like ours, wrapped in just enough air to let a voice, or a breath, or a single soft word finally have somewhere to travel. It's a tender thing to realize, this close to sleep, that this whole wide, wandering neighborhood has mostly been utterly silent the entire time, and that the quiet, gentle sound of this very voice reaching you now is only possible because you happen to be resting somewhere with enough air to carry it. Let's rest, truly, one last time before we let everything go. Everything we've wandered through tonight, every planet, every moon, every ring, every old and patient storm is simply continuing on exactly as it always has, entirely unconcerned with whether you're awake to notice it or not. It doesn't need you to keep track of it. It only needed you for a little while to rest alongside it. You can let all of this soften into impression now. There's no need to hold any of it tightly. No rings, no moons, no ancient light. Just let it all settle, the way dust settles slowly, quietly at the bottom of something still. Let your body soften again wherever it is resting. Let your breathing slow, even further now without needing to try. Let your shoulders sink a little deeper. Let your thoughts loosen and drift apart and drift away. There is nothing left to hold on to tonight, nothing to remember, nothing to finish. Above you, whether you can see it or not, the same steady sky is turning slowly, the way it always has. The same sun is resting quietly at the center of this same small neighborhood, and it will keep resting there, steady and unhurried, long after tonight has folded into tomorrow. You don't have to keep it turning. You don't have to hold any of it up. It was always going to keep going gently on its own, just like you are right now. Your body already knows how to rest. Sleep well and good night.